Let's talk about Gauss's law. The law states that the net electric flux which enters and leaves a surface is simply equal to the total charge enclosed by the surface divided by the permittivity of free space. You might be wondering what this means makes sense. But first and foremost, let's write out what we just said right on the board. So mathematically, the law says that the net electric flux is equal to the ratio of the magnitude of the charge by the permittivity of free space. In case you are wondering what this is, it's a constant which is about 8.85 times 10 to the power of negative 12. So in units, it's simply Coulomb squared per Newton meter squared. Excellent. Now we want to understand the basic concept behind this law. So let's try to consider some visual illustrations. So let's consider a sphere with a charge inside the sphere at the center. So let's say the charge is positive charge, as that would be the best charge to consider in order to describe the concept in details. So it turns out that for positive charge, they emit their electric field away from themselves. So it means this positive charge will emit its electric field away from itself in all directions. Oops. Excellent. Now, if this sphere is not a circle, it's a sphere, it contains something. Am I communicating? Perfect. If this sphere is inserted in a region where we have electric field, it turns out that we have field lines or field strengths to penetrate through the surface, and at the same time, the field strengths would want to emerge. Well, the question is, would we have the same magnitude of field strength that enters the surface to emerge out of the surface? Well, pause the video and think about it. Then after that, you can pause it and see if you have done the right thing. It turns out that you will never have the same thing, because when we have field strength to penetrate through the sphere, then this strength would actually connect and interact with the strength inside the sphere, and then we will have more strength to be emerging out of the sphere. Am I communicating? So it means if we have, for instance now, 3 field strengths to penetrate, that's electric field, okay, to penetrate through the sphere. Now they will connect and interact with the field lines inside the sphere. So if we consider the first one, which is the one I circled or highlighted, which is actually parallel to them, then it means that we will be having about 4 field strengths emerging out of the surface in this direction. Excellent. Now, what Gauss's law helps us to understand is that the net electric flux, that is, the sum of the flux entering the surface and emerging through the surface in the same direction, is equal to the magnitude of the charge enclosed by the permittivity of free space. So we can see this in much more clear way. So if this is 3E, for instance, and we can calculate that this is 4E, this is the 1E that we have inside the sphere. Now, if we sum this up, will we have what we have inside? Yes, we will. Because when we have an inward flux, then it's going to be a negative flux. While for an outward flux, it's expected to be a positive flux. So adding this up, you will observe that we have just 1E, which actually corresponds to the additional field strength the previous 3 field strengths actually interact with when they penetrate through the surface. Now, if you don't really get the clear picture of Gauss's law with this instance, let's consider the second instance. I'm very sure with that you'll get the concept. So now let's, for instance, consider a spherical surface inserted in a region where there's field lines. So if we consider another sphere inserted where we have field lines, okay, then it turns out that the same amount of field lines that enters the surface will be the same as the amount of field lines that will leave the surface. That makes sense, because nothing is being added in the process. Am I communicating? So if this is EA, that is the electric flux that actually enters the surface, remember the electric flux, the electric field strength that enters a surface is what called the electric flux, and the one that emerges out. So let's say the one that enters, let's say EA sub E enters, and the one that leaves, let it be EA sub L. Now we said for an inward flux, the associated value has to be what? Associated sign has to be negative. So negative EA sub E, and the outward flux, the associated sign has to be positive. So positive EA sub L. So what would this be? Well, it's just that we just assign different letters to them. However, they will be equal in magnitude. As you can clearly see from the diagram we have right on the board, that the field lines are the same. So this will be equal to 0. Now remember, Gauss's law said that the net electric flux, okay, would be equal to the charge enclosed divided by the permittivity of free space. Now the fact that this sphere doesn't enclose any charge, it means its magnitude will be 0. And 0 divided by epsilon sub naught, regardless of how small or how large epsilon sub naught is, the result will still be 0, which actually makes sense and corresponds to what we have. And this is pretty much enough for us to actually verify the Gauss's law. So I hope you now get the basic concept behind Gauss's law. So how would the question come in regarding this law? Well, it will come in such a way that they will be connecting. Remember, we said the magnitude of the electric flux is equal to the product of the field strength, the electric field strength, and the area of the surface in contact. And this must be equal now to Q over epsilon sub naught. So now, if you rearrange this, you can clearly have the magnitude of the charge to be equal to the product of the electric field strength, the area of the surface, and the permittivity of free space. So this equation is enough for you to actually solve for different other variables, depending on what's given to you and what you are required to find. So to make this into good use, let's consider an example. Example number 1. If the charge in a solid sphere at the center is positive 5 nanocoulombs, determine the electric field strength through the sphere at a radius of 1 millimeter. Okay, as we always do in our videos, before we proceed on solving any physics problem, we write out what we know and figure out what we don't know in order to actually set up something that will help us to figure out what we don't know. Okay, now we have the magnitude of the charge Q. It's given to us as positive 5 nanocoulombs. Well, it has to be expressed in coulombs. So nano you multiply with 10 to the power of negative 9. Micro 10 to the power of negative 6. Then milli 10 to the power of negative 3. So it depends on what you are seeing. So it means this is the same as positive 5 times 10 to the power of negative 9 coulombs. Excellent. Now we have the radius r of the sphere to be 1 millimeter. It's a distance, it has to be in meter. Then millimeter to meter is a division of 1,000. So this will be the same as 0.001 meter. Excellent. Now these are the 2 quantities we have. We are required to find the electric field strength E. Now we were not given permittivity of free space. Like I said, it's a constant, so you need not to depend on whether or not it's going to be given. But just have it at the back of your mind that epsilon sub naught is 8.85 times 10 to the power of negative 12, and in the units is simply coulomb squared per Newton meter squared. Excellent. Now we can make use of the formula we actually discussed just a few seconds. So we said that the electric field strength E multiplied by the area is simply equals to Q over epsilon sub naught. Our goal is to find E actually, so it means E would simply be equal to Q divided by the product of the area of the sphere of the surface and epsilon sub naught. The magnitude of the charge is 5 times 10 to the power of negative 9. Well, the area we are going to get that. For a sphere, how do you find its area? So for a sphere to find its area is just 4 pi r squared. If it's an hemisphere, it is 2 pi r squared. And to get their volume of a sphere is 4 over 3 pi r cube, and the volume of hemisphere is 2 over 3 pi r cube. So you might want to have them at the back of your mind as well, in case of necessity. So area of the sphere A is 4 multiplied by pi multiplied by the square of the radius, 0.001 all squared. Okay, let me do that again. Perfect. So we need to use our calculator at this point. and then have our answer plugged in. So 4 times pi multiplied by 0.001 all squared. So I got 0.0000126, then multiply by the permittivity of free space, which is 8.85, times 10 to the power of negative 12. So I'm going to insert everything right away onto my calculator. 5 times 10 is to the power of 9, okay, minus 9 to say, and divided by 0.0000126, then multiply by 8.85, again multiply by 10 to the power of negative 12. Alright, excellent. And we've got final answer to be 4.48. Okay, let me do that again. 4.48 times 10. Okay, how many tens? 1, 2, 3, 4, 5, 6, 7 to the power of 7.